Hi guys, Gabriel John here. Today, our activity is what are some properties of the solution? Our objective is to compose the evidence gathered with the prediction we made and to describe some properties of solutions based on our observations. These are the materials that we need to use. First is the water, second is the containers for the mixtures, third, the towel for filtration, fourth is the flashlight for the light to pass through the mixture, spoon for mixing, and the samples that we mix to the H2O. The first procedure that we need to do is to predict which of the given samples will dissolve first. So, as we can see here, the samples are sugar, salt, mango seeds, powdered juice, cooking oil, and vinegar. So sugar, we predict that sugar will surely dissolve. So we write check. And salt will dissolve too. And mango seeds, which are solids, do not dissolve. So they do not dissolve. Powdered juice, which is powder, will dissolve. Cooking oil will not dissolve. And vinegar will dissolve. Our second procedure is to pour 1 cup in each of these containers. So, we are going to use this cup as to pour the water into the containers. We have this 1 liter water here we need to pour it to the cup. And the water in the cup, we need to pour it in the container. So as you can see here, we have this container here. We need to pour 1 water in here. 1 cup of water. See. Another one again. We'll just have to repeat this process until all of our containers is full of water. Now that our containers is full of water, we need to add it with 1/2 teaspoon of each of the sample. We need to stir it to dissolve it as much as possible with our spoon. This is the spoon that we need to use in order to add the samples in each of these containers. And this is the spoon in order to mix them with the water. Now let's add them. We only need half a teaspoon in order to put only. And the other one is just careful to pour careful. The model seeds, which is solid, and we predicted in the first procedure, we predicted that this is not going to dissolve. So we only half of it in our teaspoon. So these are enough. Another one is the salt, which is a combination of sodium and chlorine. Salt is also a compound. So half of it. Half of it. And another one is the oil. The oil. Also half a teaspoon of oil. And the filtration plant. So by all means, I put it all in this. So we can get half of it. So half of it. Put it right over here. And the last one that we need, the last is the sugar. I use brown sugar. It's because the only availability in our house. So we can get half of it. So now that we added all the samples, we shall mix them with our another spoon. So mixing is kind of different here. So now that we've added the samples to the water and now we'll mix them, we need to describe their appearance on how they appear through our observations. And we need to write it down in the in the third column. So, as we can see here, we need to write their appearances on how they appear after they're mixed. So these what are they appear after we mix with them. First is the sugar. The appearance of the sugar is a little is gold because the water is mixed with brown sugar, so it makes like a golden. It looks like a golden liquid. So we need to write down golden brown, I think. In the mango seeds, we see that the seeds are still visible to our naked eye. So we see that it is a heterogeneous mixture. In the salt mixture with in the mixture with our salt, this is the mixture of our salt. So we see that there is still small particles of salt that visible in our naked eye. So we we should write it down here that but later on the salts will get dissolved by then. In the powder juice, the appearance is the appearance of the juice is that the water is in orange is in the flavor of the is in the color of the powder juice. So we use the powder juice, the orange, the mango flavor. So the water turns into a yellowish liquid. Oil, we know that oil is much denser than water. So we see this particle is the oil because it is much denser than the water, so above of the water. We see that because the oil is denser than the water, the oil is the oil floating the water. In the vinegar state, we see that we cannot see which is the vinegar here and the water. So vinegar completely dissolved. The vinegar is completely dissolved, which means that the vinegar is cannot be seen. So now, in the next column, we see that if the sugar the bubbles is uniform or not. So as we see here, the sugar is completely sugar is a matter of fact a uniform composition. because it is a homogeneous picture with composites, which, yeah, so we should write it down uniform. This salt the this salt in fact is also uniform. It will dissolve later on. So we will write here uniform. In aside from being uniform, Mongo C also is a non-uniform composition. We can observe Mongo seeds, the one we can still observe them with our naked eye. So that this defines that Mongo seeds is heterogeneous and is a non-uniform composition. So we write here non-uniform. Powdered juice, as a matter of fact, is uniform because the powder dissolves in the liquid. The liquid dissolves the powder. So in other words, it is a uniform mixture. In cooking oil, it is a non-uniform because the oil is non-uniform because we can still see the oil above the water. So we consider this as non-uniform because it is a heterogeneous mixture. In vinegar also is a uniform because we observe that the vinegar quickly dissolved in the water and we cannot see anything we cannot identify which is the vinegar here because it is already dissolved in the water. So we consider vinegar is a uniform mixture. So now that we've observed the appearances and if they are uniform or not, we will going to filter them in this transparent glass. And we're going to use this to filtrate the mixtures that we have created. So in the next column, as we can see here, we need to identify each of the sample if it is the mixtures, the following mixtures. We need to identify them if it can be separated by filtration or not. So first, we need to try the sugar first because we are going to try one by one because I only have one transparent glass. So we need to first try the sugar mixture. So which is the sugar mixture? Need to So we need to try the sugar mixture first, which is the sugar mixture. We need to pour it right over here, being carefully so it will not spill out. So yes, as we can see here, the filtration is it it cannot be separated by the filtration. Because as we see, it is also the same as the mixture in the other glass. So we should write so in the filtration paper in the towel we cannot see the particles anymore. So yes, we cannot filtrate the sugar sample. So you should write no. And in the next column, we need to see if the path of light can be seen in this. So we need to use this flashlight in order to see if the path of light can be seen. And yes, it can be seen. The path of light can be seen in the mixture. So we should write So we should write can be seen. So as we can see, solution is solution is another term for homogeneous mixture. In an instant, sugar is an homogeneous mixture. So we need to write it here. The sugar is a solution. So the next sample that we need to experiment is the salt sample, the salt solution, the salt mixture with the water. So we need to write it here if the salt and water can be separated by filtration. So let's see. Let's see. And this is our salt. This is our salt solution. In this case, we cannot see anymore the particles. That are on that's not particles. There's the bubbles. So we need to. Yes. Through it, we cannot see anything. So move now. Yes, as it was, the salt is just the same as the mixture as we after we filtered it. So we should write here. So we should write here. The salt cannot be separated by filtration because the salt is already dissolved in by the water. So we cannot filtrate the salt anymore by using filtration method. So yes, salt cannot be filtrated. And let's test if the path of light can be seen in the salt. Yes. Yes, a path of light can be seen. So we should write it can be seen. In Mong So yes. Solution yes, salt is a homogeneous mixture, which means it is a solution. So we need to write it is a solution. We need to write as a solution. Next in our list is the mango seeds. So we need to identify if the mango seeds can be separated by filtration. So let's identify them. Attaching now, and we need to get the mango seeds mixture, and we need to pour it right over here. We need to make sure it's not enough. And so yes, as we can see here, the mango seeds are getting separated by the water. So that means the mango seeds can be separated by filtration. And we should write yes here because it can be separated. Look at this. This is what we observed here. And now, let's see from the remaining water. Let's see if a path of light can be seen. Yes, it can be seen. You can see the path of light running around the liquid. So as you observe, path of light can be also seen in the mango seeds. And yes, mango seeds isn't a solution because it is a heterogeneous mixture, which means which means if a mixture, which means that it is separated by filtration. It defines that the mango seeds it is not a solution. It is a heterogeneous mixture. Next in our list is the the powder juice, which means so we need to identify if the powder. So the next in our list is the powder juice. So we need to identify if the powder juice can be separated through filtration. So now we've now assembled it. And the powder juice is this the mixture of the powder juice and the water. So, as we can particles. So as we can see here, this the also the same as before. Mr. House cannot be said because we see that there's none. We see that there is none here. So yes, it is not the powder juice cannot be separated, so we not know. So we need to verify if a path of light can be seen in this mixture. And yet it is not. The path of light cannot be seen through the mixture because it is full of the color of the water. The path of light cannot be seen through the mixture. It cannot be seen. And yes, we need to identify if this is a solution or not. But yet this is a solution because as we see it, the powder dissolves in the water. So you can see all powders that has all, but most that we pour through dissolved by the water. So we're going to write it here. It's a solution because it dissolves. The next thing of our list is cooking oil, and yet we need to identify if cooking oil can be separated by filtration or not. So as you can see, we are assembled again. We assembled again. So this is the mixture of our cooking oil, and yes, as we see there, the oil is still floating above the water. So let's test this out. If it can, if it is really maybe it can separate. Let us see. So we need to get a filtration paper, the filtration towel, and yeah, I don't. I'm not sure. Yes, it the yeah the it can be separated by filtration because as we see, it is now the filtration is now slimy. It's now oily because this is the oil that we poured them oils into this and allowed it to pass the water. So we need to add it here, yes. it can be separated. Now, let's see if a path of light can be seen in the liquid. Yes, it can be seen. Path of light can be seen. So, it is not a solution. Cooking oil is not a solution because it is a heterogeneous mixture, which means it contains two components. So we're going to write here not a solution because the oil did not dissolve by the water because oil is much denser than water. So the last one that we need to identify is the vinegar. And yet the vinegar is also the last one. So we need to identify if the vinegar is can be separated by filtration. So let's find out if the vinegar can be separated. So yes, it is we attach it again once more. So we need to pour the vinegar here into our filter into our I need to remove it. And yes, as you can see, it is also as the same as before. So yes, the vinegar cannot be separated because the vinegar is already dissolved by the water, and yet the appearance itself defines that it cannot be separated by filtration because the vinegar is already dissolved by its appearance. So yes, we were able to know. And let's test if the path of light can be seen. Yes, a path of light can be seen. It's a matter of fact. So let's write here can be seen. And yes, vinegar is a solution because as we can see, it's a solvent. It has the vinegar is getting dissolved by the water. So we will write here solution. After the experiment we did be able to compare the evidence gathered with the predictions we made, yung the predictions we answered in the first procedure, and to describe some properties of solutions based on our observations. So, as we see, we did we did define their appearance. We did define their appearances, and we did define if they are uniform or not, and define we did identify if they can be separated by filtration or not. We did identify if the path of light can be seen through them after we filtrate them, and we also identified if it is a solution or not. So I'm going to explain them. Sugar will surely dissolve because the water will dissolve the sugar. And this appearance after we mix them is golden brown because of the color of the brown sugar. And yes, it is a uniform mixture because it contains because it contains one because it has one phase of matter with a uniform composition throughout. and it cannot be separated by filtration because the sugar is already dissolved by the water, and the path of light can be seen through it. When we test this with this flashlight, when we test this flashlight to the mixture, and yes, it is a solution. This is a as a matter of fact, is as it known as homogeneous mixture. Salt, in other hand, it's dissolved also, and its appearance after we mix it is the components can be seen, but later on it will get dissolved. And yes, as we go on through our experiment, we observe that at first we observed that the components can be seen at first, but as we went through our experiment, the the salt the salt slowly dissolved by the water. And yes, it is a uniform composition, and it cannot be separated by filtration because the salt, as I said, as we go through our experiment, we the salt is getting dissolved with the water. And yes, the path of light can be seen as we test our flashlight with it, and it is a solution, and also called also homogeneous mixture. Aside from that, mango seeds will not dissolve. Why? Because mango seeds are solids, and liquids cannot dissolve solids because the molecules are packed into each other in solids. So the molecules in the water cannot dissolve the molecules in the solid. So the appearances of the mango seeds after we mix it is that the seeds can still be seen even after we mix it with our spoon. It's because yes, the water can't dissolve it, and it's a non-uniform mixture because it has two or more phases of matter, and it can be separated by filtration because it because the in as we filter out the mixture of the mango seeds in the water, the mango seeds is left in the towel in the water, and it allows water to pass through the seeds through the container to the transparent glass. And yes, a path of light can be seen in it as we test it with our flashlight, and it is not a solution. So as it is called a heterogeneous mixture, which means its components are visible after it is mixed. And yet is it true? And yet it is true that the components are visible. And in powdered juice, we see that the powder is dissolved with the water. So we predicted it, and its appearance after we mixed it is its yellowish liquid because of the flavor of the juice, and its composition is uniform because it has only one phase of matter, and it cannot be separated by filtration because the powder is already dissolved by the water, and the path of light cannot be seen. Why? Why? Because the coloring blocks out the light from the flashlight that we tested it, and it is a solution because the water dissolved the powder. The cooking oil, we predicted it that it will dissolve, and its appearance is the oil is floating above the water, and as it was the oil is much denser than water, and even if you mix it hardly and quickly, it will stay afloat atop the water. And it is a non-uniform mixture because oil and water are both liquids, but their density is different from each other, and it can be separated by filtration because, as we observed, the oil sticks out in the towel, and it allows pa- and it allows to and it allows water to pass through the transparent glass. and the path of light can be seen through it, but and it is not the solution. It is a homogeneous and it is a homogeneous mixture. In vinegar, we predicted that it will dissolve because both are liquid. So, but the water can dissolve the vinegar. So the appearance is the appearance of the mix is that we cannot see the vinegar anymore. We cannot see the vinegar anymore because it is already dissolved by the but it is quickly dissolved by the water, and its composition is uniform because it's the same as the powdered juice, salt, and sugar. There's only one phase of matter, and it cannot be separated by the filtration because yes, the vinegar is already dissolved, and the path of light can be seen through it, and it is a solution. And as it is a homogeneous mixture. So that's all for today, guys, and I hope we will see each other in our next activity. Goodbye and have a great day.